we are going to figure out printing the left view as well as printing the right view. So what is the left view? Let's say this is your binary tree, and what I have to do is, if I see it from the left side, all I would see is I would see 1, and then on the next level I'll see 2, next level I'll see 4, and next level I'll see 8. Right, so 1, 2, 4, and 8. So that will be a level order traversal, a right side view of it. Let's say if somebody can say that, oh, all you want to do is you can actually go and print the root and then keep going on the left and print the values. That'll actually be true for 1, 2, 4, 8. But if, let's say, 8 is not there, so if 8 is not there, then it will print 1, 2, and 4. But in this case, our left view should actually print 1, 4, and 9. 1, 2, 4, and 9. 1, 2, 4, and 9. This one. If we just keep going on the left, we'll actually miss the 9. So we don't want to do that. Right? So in our case, what we'll do is we'll just do a level order traversal, and we will actually, in level order traversal, we will actually see the video for the level order, which is in the playlist. And in the level order traversal, all we do is, if we print the first value, if we have printed the first value, what we'll do is we'll not print the other values. If we have not printed, or like when we have changed the level, when we change the level, at that point there's a boolean variable that we'll keep, and we'll actually flip the boolean variable. And so that is all that we need to do. If we want to print the right level, if we want to the right side of it, if we want to print the right side, what we'll do is we'll actually keep a variable which will keep track of the last node, whatever was the last node. And when it actually changes level, at that time we'll check which one was the last level, last node, and whatever was the last node, we'll just print it. So first last node will be 2, and then last node will be 3. And when we change the level, then when we change the level from 7 to 8, the last node will be 7. When we change the level from 11, the last node will be 11. So we'll print all of them. Let's actually see how we can write it in the code. It's basically similar as the level order traversal. So here we actually have a class of node, and then we have a binary tree class, a pretty empty class. And in the main, what we do is we actually have a create tree, which will create this particular tree and then return the node to us. Okay, so let's see. We'll say public void print left view, print left view. Okay, so that is there. And what we'll do is we'll check if root is equal to null. If root is equal to null, we just return. Otherwise, we'll actually have a queue of node of t, and we'll say q is equal to new linked list, and then we'll say q dot add, and we will add root to it. And the next thing that we'll do is we'll actually add a null to it. This null will actually figure out when our new level changes. Okay, we'll probably need boolean b print is equal to true. So initially we are printing, we have to print the root, right? So we are saying b print is equal to true. So we'll say while q dot is empty, while the queue is not empty, while the queue is not empty, what we'll do is we'll dequeue the queue. Node is equal to q dot remove. So remove the node. We'll check if it is null. So we'll check if node is not equal to null. If node is not equal to null, earlier what we were doing in level order, if the node was not null, we were just printing it out. Over here, what we'll do is we will actually we'll check if b print is equal to true. So we'll check if b print is equal to true, then only we print it out. So we'll say so we'll print node.data. I think that should, we'll just do a println. We'll just print the node.data. Okay. Once we print the data, we'll actually flip the b print. It's equal to, we can actually say false. We'll just say b print is equal to false. Okay. Then what we'll do is we'll check if node.left is not equal to null. We will actually enqueue it in the queue. So we'll say queue.add node.left. We'll do the same for right. Okay, so we do both of them, else the node was null. So the node was null, we'll just go to a new line, and then we will check if we will check if queue dot is empty. If the queue is empty, then we break out of the loop. And we'll say b print is equal to true, and we enqueue another null, saying that this is the end of the level. Okay, so this is end of while. And this is the end of function. Okay, so I think that should actually do it. So we'll come over here and we'll say tree dot print left view, and we'll run this. So it gets 1, 2, 4, and 8, which is correct. I think it's printing a few more lines over here. Where is this? Print ln. We don't need this. Okay, so that is good. So we'll run this again. It says 1, 2, and 4, and 8, which is actually the correct one. So let's actually do a right view also. This is basically just a copy paste of the same thing with just a few modifications. So we copy that, we print this, and this is print right. Print the right view. Okay, so in the print the right view, what we will do is we don't want the b print. Okay, and what we need instead is a variable which will keep the track of the last node. So we'll say last node node let's say right now it is null. Okay, so we actually remove the node. If node is not equal to null, then what we'll do is we don't print anything. We'll just say last node is equal to the current node that we have. Okay, we add the values and stuff like that. If the queue is empty, so over here what we'll do is since when the node is null, then that means that the level has changed. If the level has changed, we'll just print the new node. So we'll say and we will say last node dot data. Okay, so that is good. And if the queue is empty, we break out, and queue null. I think that should basically just do it. Okay, print the right view. So print the right view for this one should print us 1, 3, 7, and 11. 1, 2, 4, and 8, 1, 3, 7, and 11. Okay, that works. Okay, we'll see you in next video.